Right now, beneath the frozen surface of a moon 390 million miles from Earth, there is an ocean. Not a dried-up basin, not a trace of ancient moisture, a living, churning, saltwater ocean, larger than every ocean on Earth combined. And something might be alive in it. Europa, Jupiter's ice-covered moon. For decades, it was just a dot in the sky, but the more we've looked, the more it looks back. And what NASA's Clipper mission is now revealing changes everything we thought we knew about where life can exist in this universe. Here's what I want you to hold on to as we go through this. Scientists don't just think Europa might support life. Some of the most respected astrobiologists on the planet believe it may be the single most promising place in the entire solar system to find it. Right now, today, alive. I'll tell you exactly why they think that, and the answer involves something happening on Europa's ocean floor that you almost certainly haven't heard before. First, let's understand what we're actually dealing with. Europa is one of Jupiter's 95 known moons, but it is in a category entirely its own. It's roughly the size of our moon, about 90% of the diameter, but that's where the similarity ends. Europa's surface is a shell of water ice, crisscrossed with reddish-brown streaks that look eerily like cracked skin. Those cracks are called lineae, and they tell us something extraordinary. The ice is moving, it's flexing. Something beneath it is alive with energy. How do we know there's a liquid ocean under all that ice? 3 lines of evidence, each one more compelling than the last. In 1995, NASA's Galileo spacecraft flew past Europa and detected something remarkable, a magnetic signature. Europa was generating its own magnetic field, and the only way a moon that small can do that is if there's a layer of electrically conductive fluid beneath the surface. Salt water fits perfectly. Then images from Galileo showed the surface ice had rotated slightly out of alignment with the moon's interior, a phenomenon called non-synchronous rotation, which almost requires a decoupling layer of liquid between the shell and the rock below. And then there are the plumes. In 2013, the Hubble Space Telescope spotted what appeared to be water vapor erupting from Europa's south pole, geysers shooting ice and water particles up to 125 miles into space. A frozen, dead rock does not do that. So the ocean is real. But here's the question that actually matters, and it's the open loop I promised I'd close. Why would anything be alive down there? To answer that, we need to talk about a discovery made right here on Earth in 1977 that shattered every assumption biology had about life. Deep in the Pacific Ocean, researchers in a submersible descended to a volcanic vent system on the ocean floor. They expected darkness, cold, and emptiness.
What they found instead was an explosion of life. Tube worms 6 feet long, crabs, clams, fish, all thriving in total darkness in scalding, toxic water with zero sunlight. These ecosystems run not on photosynthesis, but on chemosynthesis. They eat chemical energy from the rocks and vents themselves. Life, it turned out, doesn't need the sun. It needs heat, water, and chemistry. Europa has all 3. Europa's ocean floor is almost certainly geologically active. The same tidal forces from Jupiter's immense gravity that flex and crack the moon's ice shell also squeeze its rocky interior, generating friction, generating heat, and almost certainly driving hydrothermal vent systems on the ocean floor. The exact same setup that produced our earliest life on Earth 4 billion years ago. Same ingredients, same energy source, running right now hundreds of millions of miles away. Now here's the part that escalates this from fascinating to staggering. In 2023, scientists published new analyses of Hubble data and data from the James Webb Space Telescope, suggesting that carbon dioxide, a molecule deeply tied to biological chemistry, is concentrated on Europa's surface in regions that correspond to upwelling from the interior ocean. Carbon, oxygen, hydrogen, nitrogen, the 4 pillars of life as we know it, apparently present and being actively cycled between the ocean and the surface. This isn't residue from an asteroid impact. The distribution pattern points to an internal source. Europa may be exhaling chemistry that life needs. And then there's something even the scientists didn't fully anticipate. Europa's ice shell, under continuous bombardment of radiation from Jupiter's magnetic field, may be generating hydrogen peroxide on the surface. When that ice gets recycled back down into the ocean, which geological models suggest it does, it delivers a powerful oxidant directly into the water. On Earth, the combination of oxidants and reductants from hydrothermal vents is exactly what drives the chemistry of cellular metabolism. Europa may have a natural planetary-scale chemical battery running continuously, powering potential biology at depths we've never seen. Let me give you the full picture of what we're looking at. An ocean bigger than all of Earth's oceans, estimated to be 40 to 100 miles deep, kept liquid for potentially billions of years by gravitational tidal heating, with a rocky floor that may be dotted with hydrothermal vents, with the chemical building blocks of life being actively produced and cycled, with a radiation-driven surface chemistry that delivers oxidants into the water. This isn't a long shot. This is a habitat, a potentially complete, self-sustaining biosphere underneath the ice of a moon orbiting Jupiter. NASA's Europa Clipper, which launched in October 2024, is on its way to find out. It's the largest interplanetary spacecraft NASA has ever built. It will make 49 close flybys of Europa beginning in 2030, scanning the ice shell, sampling the plumes directly, mapping the magnetic field, and searching for signs of current geological and potentially biological activity. If those plumes contain complex organic molecules, if they contain the specific chemical signatures of biology, we will know. For the first time in human history, we may have a direct answer to the question we've been asking since we first looked up at the stars. And here's the thought I want to leave you with, the one that shifts the frame entirely. We've always imagined the search for alien life as a search for something far away, something on a distant exoplanet around another star, thousands of light years off. But Europa is in our backyard. Right now, if microbial life exists under that ice, it has been there for billions of years. It evolved completely independently of life on Earth. Two separate origins of life in the same solar system. If that's true, life isn't rare. Life isn't a miracle. Life is what the universe does when you give it water, heat, and time. And the cosmos is full of all three. If this changed the way you see the night sky, hit like. It genuinely helps this channel reach people who need to hear this. Subscribe so you don't miss what comes next. We're going deep into Enceladus, Saturn's moon that's actively venting its ocean into space right now, and what Cassini found there might be even more shocking than Europa. See you there.